Hi, and welcome to Conversations with Des. I'm your host, Des Blanchfield. Today, I have the privilege of being joined by Cristina Rodriguez. Now, Cristina is Vice President in the Data Center Group and General Manager of the Wireless Access Network Division at Intel Corporation. Cristina, welcome to the show. Thanks for making time to join me.
Hi, Des. Thank you so much for having me.
An absolute pleasure. Now, allow me a moment just to introduce you to our audience. So Cristina is both Vice President in the Data Center Group and General Manager of the group's Wireless Access Network Division, as I mentioned. But Cristina essentially leads Intel's efforts to provide innovative wireless access network solutions, including 5G wireless access technologies and all relevant emerging spaces in there. Now, we're going to talk a lot about the whole space of radio access networks, Cristina, but before we do that, I wonder, there's no secret that the world's currently enduring a global pandemic with COVID-19 and the whole coronavirus challenge. I was just wondering if I could ask you, how are you doing personally with this whole challenge of not just dealing with the COVID-19 global pandemic sort of pivot to working from home, but just the balance of life and work now that people seem to be doing, we're enduring, what did I hear the other day? Zoom fatigue and so forth, and also just juggling the 24/7 challenge of sort of working from home and not having clear boundaries between where home and work is. And how are you doing personally?
Thanks for asking this. And I'm doing well, and I hope you are doing well too. Life feels disrupted, of course, for all of us. I missed the interaction with my colleagues. I definitely missed visiting my customers. In normal times, we will be doing this from our Intel office here in Austin, Texas. Instead, I'm in my home office. with my door locked, so my kids don't walk in accidentally in our conversation. So we're adjusting and continue doing the best to support our customers.
I'm so glad to hear that. Yes, I've seen a number of interviews and certainly a number of meetings I've been on myself, particularly via sort of the video conferencing, where we've had that moment where that British reporter from Southeast Asia had his kids run through the door and then his partner comes screaming through to grab them, or puppy dogs and cats jump on the desks. But I think in many ways it's unfortunate that it's a global pandemic is what this is about, but I think there's been a rehumanization of our working experience. One of the things that strikes me with regard to Intel Corporation, Intel as a global business has had to respond to this whole global pandemic in every region around the world, from supporting staff through to their partner ecosystem, manufacturing, supply chains, and they've had to do it in a phased form, and that is that at a country level, we've had to sort of deal with it at a point in time. But when you think about large organizations like Intel, you've had to cope with the emergence of it through Southeast Asia, then Oceania, then Middle East and Europe and the UK, and now North America and South America, and of course, all of the various territories and states of Africa that you operate in. How are things going at Intel, and what's Intel's response so far to this whole global pandemic being like?
Yeah, no, that's an important question. And first of all, regarding the COVID-19 situation, we have, when it comes to it, Intel's top priority in managing the situation is protecting the health and the well-being of our employees. And we tell over and over again, this is our number one top job. While doing that, also continuing, of course, operating and supporting our customers around the world. As we know, technology has played a very important role in this situation. We are a living proof of that. Intel's technology and products are the backbone of this digital infrastructure that is so needed. So we're applying Intel's technology and expertise to combat this pandemic, and we're committed to help in the communities where we operate, and we are mobilizing resources to support local needs. I will tell you also, Intel recently announced pledging an additional $50 million in what is called a pandemic response technology initiative. These funds contribute to our focus to combat the coronavirus through either accelerating technology at the point of care for patients, accelerating or speeding the scientific research, ensuring that we support, that we enable the online learning. So this is all in addition. We had already committed to or announced a 10 million donation to support the local community. So this 50 million is in addition to that. So you can imagine, I feel really honored and proud to work for a company that has such a sense of social responsibility.
Indeed, and congratulations on all of that. I think it's astounding that organizations like Intel, who have so many challenges, and I see it being such a multifaceted challenge, because not only do you have to, as you said, protect your own staff and then keep the business operational and the lights on, you've got to support an ecosystem of partners and integrators and resellers around the world, as well as your own customers and their customers. And, I think a lot of people don't realize that when we see, whether it's food delivery people with mobile devices or tablets delivering food and orders, whether it's frontline responders and emergency people out there, whether it's police, fire, or health and hospitals and so forth, they're carrying devices with Intel architecture chips and so forth in them 24/7. And you've got to be ahead of this whole curve. And above and beyond that, you've made some significant contributions financially and otherwise. And I think that's very exciting, and congratulations on that. And likewise, I think, anyone inside the Intel team should be very proud of that capability of meeting this amazing challenge and keeping the lights on. I wonder if we could talk about radio access networks. Obviously a key focal point for yourself and your role. Intel's had a number of related announcements through Q1 this year of 2020 that were very exciting, in particular with new members to the Intel architecture family. Specifically, you announced two really exciting new Intel architecture platforms with both the second generation Xeon scalable processor and the Atom P5900 system on chip. Both, in my mind, game changers in their own right. One in the data center and cloud platform space with the second generation Xeon scalable processor, particularly with its built-in capability for machine learning features and so forth. And the other at the edge, as in edge networking, edge computing, and certainly the access space that we're going to talk about today. I wonder if we could just maybe start out with a brief introduction, particularly to the Atom P5900 in the context of radio access networks, or RANs, and how you see the Atom P5900 playing into that whole edge networking and edge computing space. And I guess, what it makes possible in the area of radio access network transformation now.
Absolutely, and this, I am super passionate about RAN and everything that is going on, and 5G, how lucky we are to be living a moment from the technology point of view that is so transformative, and so it's gonna change the life the way we know it, right, for a better, in a better way. But going to your question, let me start saying that the Atom P5900 is designed from the ground up for 5G wireless base stations, which are at the heart of the radio access network. So let me talk a little bit about that. So to put it in a context for those that might not be as familiar with the base station. So the radio access network is that part of the telecom system, right, that connects the end users, right, the phones or whatever end user, through the rest of the network through a radio connection, right? Traditionally, that has been done. The way that's done is all happen at those cell towers that you drive by. If you are like me, since you're looking through the window to see when those antennas, 5G antennas, are showing up, and you tell your kids, look kids, this is a 3x3. But that's where traditionally those base stations are located, and they have two main components. They have the remote radio head, which is up there in the antenna traditionally, and the baseband unit that is at the bottom of that cell tower. This architecture, this configuration has very high requirements when it comes to performance per watt, right? Performance per power. Going back to your question, Intel Atom P5900 was optimized to really deliver outstanding performance per watt for the key workloads that run in that base stations. And that was designed for 5G, high bandwidth, very low latency. You know, that's an important aspect in 5G. And basically, just it's in a very it's an SoC, 10 nanometer SoC, by the way, that integrates CPU cores and integrates network acceleration, right? So it combines a highly efficient compute, again with providing ultra low latency. It has accelerated throughput. It has 100 gigabit per second of connectivity. So just to put it in perspective, I'm talking about IPsec and IP forwarding that can happen at 100 gigabit per second. So truly leadership, transport, the secure transport kind of functionality. And we have also a very efficient load balance that makes sure the workload is load balanced through the cores. So again, really is a beautiful device. This is the first standard high volume silicon for 5G radio access network. I mentioned 10 nanometer SoC, and this is the first time that we're bringing Intel architecture to this market, right? And by doing that, now we have a consistent architecture that goes from the core to the edge, where customers can realize software reuse throughout the network. And by doing that, you know what that means for time to market and just investment in R&D. So now we have a common platform where customers can innovate. I would say that our customers have responded very, very well. We expect, we're seeing leading providers across the globe delivering solutions based on this platform. I don't know if you have heard, but we are, and I'm happy to say this, we're now expecting Intel to be the #1 silicon provider in base station by 2021, which is a year earlier to what we first predicted. So very, very exciting product.
Wow, that is fantastic. Yes, I mean, there are a number of key points I'd like to just retouch on. I mean, as you mentioned, you've now got Intel architecture, or IA as we refer to it, from essentially the core platforms and data centers and the cloud infrastructure all the way out to the edge now. And as you said, essentially at the top of poles, at the end of wire for access points. Which both in the telecommunication space and also other spaces where it's not just necessarily handsets and mobile devices, but autonomous vehicles, IoT sensors. We're also going to see this now, I imagine, pivot into manufacturing and robotics and other spaces, high density retail. Because I think the thing that people often forget is that we normally would use something like Wi-Fi 802.11x to connect devices at the end of the network at that level. In non-telco spaces now, we can sort of see 5G connecting millions of devices in the same dense infrastructure and end-to-end. But the big thing for me I was going to highlight there was that you've got that same consistent platform, essentially at binary level, from the high-end CPUs like the new second generation Xeon Intel scalable processor, all the way out to the edge. And so when we think about these virtualized environments of either virtualized or cloud, and, you know, particularly when we've now got, you know, containerized sort of, Docker and Kubernetes environments running from one edge to the other, your code can be run in either the biggest or the smallest part of the space. And so we can now see these deployments run from end to end or edge to edge, and the logic can sort of follow it. I think this is going to be a significant game changer because it dramatically reduces the cost of development and integration. You don't have to have multiple proprietary platforms to build for. And you've got the performance piece. And one of the things I really loved about the chip, which I'd love to learn a bit more about, is you put a bunch of load balancing capability into this to manage traffic going through. I wonder if you could maybe just briefly talk about what that brings about.
Well, it's about how you can efficiently route your packets, right? What needs to go to the cores, how do you route, where do they go? So it's just it's important to have a efficient workload, dynamic workload, a load balancer that knows how to deal with the packets and can guarantee that throughput that you want to have at all, that you want to have in your system.
That's certainly exciting, and in the past we might have had very specific application-specific integrated circuits for this, and you know, whole bunch of complex infrastructure. Now we've got this great CPU sort of platform system on chip, as it were, to integrate this. I think it's going to create a whole bunch of new innovation, particularly as we see, you know, autonomous vehicles and robotics get out into the field. I think we're all used to sort of, when we think about radio access networks, as you said, that whole infrastructure from the access point of the devices through to the switch fabric and the core network. We often think about handsets. We maybe think about mobile devices or tablets, occasionally laptops wirelessly, but we tend to forget about the bulk of what I think is really going to connect now, which is all the other things that are not mobile phones and new innovative solutions. This brings to mind the fact that the telco industry has essentially undergone significant disruptive transformation over the last decade, in my mind, especially in how radio access networks are implemented. Particularly with the pivot to virtualized and cloud software-defined infrastructure, software-defined networking, network function virtualization, and particularly to meet this rapid emergence of 5G and then eventually other technologies around it like IoT. I wonder if you could sort of share some of the insights you've seen around key trends that you're witnessing and participating and help develop as they evolve now around the RAN deployments. And maybe some examples of the types of RAN deployment models you're seeing emerge, because I mean, I think a lot of people are coming at this with a very new sort of view of how RAN can be done now that it can be software defined and orchestrated and automated. Could you share some insights around what you're seeing out in that whole RAN space and where you think we're heading with these current trends?
No, absolutely. And this type, of course, what you were saying before is important. The world is changing, right? So they say that what we are seeing with 5G and the edge, which they're both very interdependent on each other. What we're seeing is now all these possible use cases that are bringing additional requirements, right? And it's what you were saying, the mission critical, the type of use cases such as autonomous driving or remote surgery. For example, that we're not talking now about a phone. Exactly, we're talking about a much more complex use cases that requires ultra low latency, ultra reliability and low latency, for example. Or we could be talking about massive IoT with millions and millions of sensors and data that need to be collected and need to be analyzed. Or we could be talking about enhanced broadband with, when we need to support a tremendous amount of video at a very low latency. So all this now adds addition possibilities, but also challenges and unleashes innovation in order to deal with all this. So when we look at the RAN, we see a broad market drivers, right? In comparison with 4G, the 5G build out will require a much more diverse of solution deployments, right? One size no longer fits all, right? If you think about it, just to mention some of the things that are happening here, we're going to see deployments that are distributed right there at the cell tower, like the one that I just described, very traditional. But we're going to see also centralized deployments. We're going to see full cloud native deployments, and we're going to see, for example, integrated devices or integrated solutions all are there at the radio side. And then on top of that, there are going to be different ways to split that architecture, and you probably have heard the 7.2, different splits in the wireless stack. So all kind of possibilities there, and then in another dimension at the same time, there is macro, there is micro, there is various small cells, capacities, and form factors that are going to be deployed, right? We see licensed spectrum and unlicensed spectrum. We see a virtual, a public network, but we also see private network. You mentioned that too. So there's all kind of different possibilities. When you look at the radio, we have sub-6, we have millimeter wave, we have multiple frequency bands, we have different bandwidth carriers, we have massive MIMO. So there's so many things going on. And again, at the end, the conclusion there is, hey, one size doesn't fit all. There are going to be multiple type of deployment, but also we need to do something to be able to address all this in a way that is also cost effective and that it creates innovation and unleashes new type of services and models, right? And business model. So you know, we see what we are seeing is just going into more specific is talking about the trends that we're seeing. We see a continued play of the highly optimized networks, right? And at the same time, we see how and we're going to see, by the way, we're going to see the operators wanting to leverage the investment that they have done so far, right? So the network that exists today is going to have to enable 4G and 5G for years to come. But at the same time, there is this thirst, there is this need to also bring the cloud type innovations and technologies that have been there in the cloud to bring it to the RAN to take advantage of the benefit that brings. And as you know, the industry and Intel have been a force in that, and have played a leadership role in that. We have for years, right, for a decade now, we have been looking at how to add virtualization to the network, especially to the core network. And you've seen how this year, by the way, we are in the core side, we're seeing that crossover where now more than 50% in 2020, more than 50% of the network. We see analysts saying that more than 50% of the network is going to be virtualized in the core side by 2024, and 80%. So this is happening has been happening in the core. But now the next thing to do is, well, can we do this in the radio access network? And we see a lot of operators very interested in making it that happen, bringing those technologies, bringing the principles of network function virtualization and software-defined network, and you know, just the server technologies, and with that the server economy of scale into the radio access network to add more value, to extract more value, so we can have a common cloud software platform from the core to the edge, including the far edge. We are able to do, or they will be able to do, faster deployment of new features and new software. They will be able to enable more services, more revenue models. So just in general, taking advantage of that common platform and that server economy of scale.
Indeed, it's a very exciting time. I regularly say that I wouldn't want to be alive at any other time. The things right. things that we can do now are so exciting, and I loved your point around the idea that a radio access network is not necessarily a radio access network anymore. You have small, medium, large, extra large, and micro, and virtual RANs, and I think this is now creating some of those amazing gateways for this innovation, because once upon a time there were some very large sunk costs to roll out physical infrastructure, from data center compute all the way to cable in the ground to things at the top of poles, and you had very rigid and fixed environments to try and innovate in. Now, the world's sort of our oyster of creating these things. There's really almost no limit to what people can imagine and create. And I love the idea that we can now drive this all the way out to the edge of the network with the system on chip with the Atom P5900, because we've got that flexibility to create new concepts, new ideas, new designs, new models, deploy them quickly, and use that continuous development, continuous improvement model that we sort of saw came through enterprise and now is helping disrupt the telco space. And it's great to see Intel leading that space. I also loved your comment around the types of uses of the radio access networks. Now, I think we've seen a big shift from even basic services like internet access, where we might have had sort of cable in the ground and broadband to the house. Fixed wireless access, I think, is going to be a massive disruptor that people can get high throughput, low latency, fast bandwidth to their house or their premises and business, particularly for small business. We already know this is going to be a big success story for emergency services, and we've certainly seen that in North America with the likes of the FirstNet solution. So I think each of these is going to change significant parts of what our human life and experience is going to be. I just can't wait to see what's around the corner now.
Absolutely, it's fascinating. It is fascinating. I can't wait to see more.
It's pretty good. I mean, it's almost there. What do they say? The sky's the limit. The other thing that strikes me now is that sitting in boardrooms with some of the telcos, I have a really privileged situation to be talking, as I'm sure you do, on a day-to-day basis more than I do. But I have the privilege of talking to as many as 61 different carriers and telcos around the world at various times of the year, particularly at the OSS, USS user group forums and so forth. Recently was one in New York. There was, I think, 63 representatives from 61 carriers and telcos and CSPs and so forth. And one of the things that struck me was there was a lot of co-compete, co-opt. So even though they might have been competitors per se, they were looking at how they were going to integrate their network so that if one provided a particular service and the other provided a different service, how they could do handoff. And this whole virtualization and software-defined capability meant that a piece of logic that sat inside a container that could be instantiated in milliseconds and create a call connector or a virtual WAN or a virtual VPN connection or even a virtual RAN could happen instantly, deploy across multiple carriers, provide a service, and then die, and naturally just do that. So, once upon a time, we used to build this infrastructure and hug it like pets and hope it didn't die. Now we treat it like cattle. We instantiate it, we let it run, and we kill it, and we move to the next one. And I think this is an exciting time as well to see this co-create, co-opt, because I think telcos and carrier service providers are under increasing pressure to achieve this whole reduced time to market and reduced time to ROI,
right,
particularly as they transform both their legacy 3G and current 4G and LTE environments, and while they're deploying new environments to support the likes of 5G. I wonder if you can share some insight around how Intel's been working with these telcos and CSPs to meet that challenge, because they're broad and they're varied. And what should some of the CSPs be doing now with Intel to ensure that they're able to meet this rapidly evolving market and the demand for new innovative solutions?
Yeah. So again, right, the RAN infrastructure is evolving to support a number of new use cases and even industry verticals, and the communication service providers have many options for architecting their RAN infrastructure, and there is an increasingly demand for flexibility and cost-effective solution. And to address what the COSP needs, we offer a broad portfolio of networking products and networking IP. You mentioned two of them that were announced late February. Number one, the new second generation of Intel Xeon scalable processor, and what we just talked at the beginning, the Intel Atom P5900 platform. But in addition to that, we have FPGAs, we have ASICs, we have structured ASICs, we have Ethernet devices, and then we have software, for example, because it's important that component to all the software that we provide, but also the software that we enable together with the ecosystem that goes from making sure that you have a really efficient packet processing all the way up to the orchestration and all the interfaces between that, and then specific products for making it easy for programmers to program, such as edge software such as OpenS and the software that we have in the open Visual Cloud. So it's a complete. We have a very, very broad, and that's just a example, very rich, very end-to-end kind of portfolio to help our customers and the service providers to address the needs of what they want to accomplish and what they want to do. I tell you, there is I'm going to talk a little bit more about the virtualized RAN because again, there's a lot of momentum. You're seeing that too. There's a lot of momentum in the industry, and I'm going to mention a few examples. We had there's Rakuten, right, who just launched early April. They launched a commercial scale end-to-end cloud native network for LTE. They're gonna follow up with a 5G in June. But again, that's they're aiming there for higher levels of agility and efficiency and cost benefits. We have, for example, Telefonica, who has also announced a partnership with an agreement with multiple, with the ecosystem and collaboration. We're part of that, where they are are expressing their design to work on Open RAN technologies. We see, for example, so that's also another example. We see also earlier this year, Deutsche Telekom and VMware announced also collaboration on an open, intelligent virtual RAN. So there's many other examples. And one of the things that I want to mention too, that we're helping in there as part of how we're helping to make this happen for our customers. We offer a FlexRAN architecture, right? The FlexRAN architecture we have proved that is the right architecture to develop the virtualized, to deploy the virtualized network. And together with that, the architecture is basically is based on Intel Xeon processor from plus some dedicated acceleration with, for example, on an FPGA. But together with that, we also offer a FlexRAN reference software. And this is basically the layer 1 software running on Xeon, which, layer 1 is the most, is the more highly compute intense workload. So we offer that as a starting point for a customer to take it and then have a accelerate their development. We have more than 80 companies right now licensing FlexRAN software. So again, a lot of momentum, and not just momentum, right? They're proof, they're commercial and trials, proof points that make us feel very confident with and very happy with the progress.
Congratulations. And when you say 80 organizations working on this, that's no mean feat. I mean, these are very large organizations. They are often struggling with a lot of very big pieces of infrastructure to move with, and it's very hard to turn and change direction. So for them to be moving that rapidly with you is fantastic. One of the things I'd love to hear just a little more, if you can, is sort of what some of that journey has been like for those partners and the early adopters, particularly when they're looking at the likes of the Atom P5900. I think in the past, a lot of telcos have been very introspective. They've been internally focused, trying to do it all themselves. It seems to me there's a trend now that they're reaching out to Intel early, right from the whiteboard sessions, from the early design point of view, and looking at you to sort of help guide them and direct them around the best ways to design and implement these radio access networks and all these different divergent approaches, because it's one of those areas where it's moving so quickly that no one can do everything. As you said, not every RAN can be everything to everyone. And the same way, I don't think any organization can be everything to every customer. I see them now coming to Intel as much, much earlier than they might have traditionally, often when they're sort of just thinking about the physical infrastructure, some of the software components, but now also from, I guess, design and professional services to help them and guide them through that journey of how to avoid some of the pitfalls to get those rapid, time to market and rapid reduced time to return on investment, because time is ever important, and also time is money. Are you seeing more and more now that organizations in the telco and carrier space are coming to you far earlier in those decision points than they might have historically to get that support from Intel and get that guidance and support around design and implementation?
No, that's a very good comment. I would say the entire 5G, not just the RAN, but 5G and Edge for that matter. This is an ecosystem effort, right? This is an industry effort, and there are going to be many players and many learnings that will happen from the different parts and in the industry, right? And Intel has worked very collaboratively with the telcos, with the service provider, over the last 10 years, but even as you were saying, even continue doing that in the radio access network to satisfy whatever type of deployment they think is the right one for the specific their specific case, right? And so we again, that software is an important part of it, and taking advantage of the software that exists, the reference software that we provide, taking advantage of the learnings that others are going through. There's different aspect to when you're doing this, the virtualized run. There are multiple layers to this. Is the layer 1 software, is the layer 2 software, is the orchestration layer, is the integration of this. So there are many components, there, and it's important that we share the industry, right? Have forums and where to discuss how to do things in the better way, and how to learn from the past. And there's multiple forums and alliances that are helping making this transition easy. And we're super happy to be part of that and be here for our customers and help and provide whatever help, either expertise or with our IP product, to accelerate this and to make sure that they are successful.
Indeed. In fact, when we think about the radio access network space, I'm struck by examples where in places like India, for example, we have RANs being deployed that are data only, where we're not carrying voice on them anymore because they're a very low cost entry-level sort of SIM card prepaid plans where you're using an app to make the call as opposed to normal voice, where it's often heavy on the network through all the 54 territories and states of Africa, where people may not have a lot of money to their name, and in many cases not even connected yet. They're getting their first phone and it's going to go straight to 5G. That's going to be an interesting thing when their expectation of normal is 5G. They've never even heard a dial tone. So I think there's going to, it's going to be an absolute need for carriers to look at not just the innovations, but how to disrupt themselves, because otherwise the market and consumers will disrupt them. Cristina, I wonder if I can ask you one last question before we wrap up then. One of the other areas around the space, given that RAN is in many ways a very niche space, and that is that in the carrier space, we all know about it. We know what radio access networks are. In the enterprise space, they may not be often familiar with it. In the consumer space, they probably have no idea. It's just some magic that happens. A lot of the organizations I'm talking to are admitting behind closed doors, let's say, and sometimes a bit more openly, that they're a little caught out occasionally where they've not made time to think about the relevant skill sets they've got. Do they have the appropriate mix of software developer and engineering and project teams to implement virtual RANs or software-defined infrastructure? So they're now having to go to the HR departments and say, reskill some of our people, retrain them, recertify them, work with people like Intel to get those certifications, or go and hire some new people. And also how to change their operational model from sort of traditional PMBOK and Prince 2 waterfall project management to agile and software development in that sort of cloud design principle. I wonder if you could offer some insights and some advice and thoughts and potentially some actionable takeaways that some of the carriers that are looking to innovate and transform their own businesses might consider with some of those areas where they may be thinking a lot about the physical infrastructure, the virtual infrastructure, and the types of services they can deliver, but may not have realized that they probably need to have a good look at the skill sets and the resources they've got to do that, such that if they run a project, they don't have a 6 or 8 week wait to find a human that even has the relevant skills to have that conversation about the technology or to develop things.
Yeah, no, that's a very good point, right? As things change and progress and new technology emerges, or even you need to take technology that exists in one area, but we need to adapt it to another segment, to another area. It's all about the people that is going to carry that task, and you need to have, if you're going to embark on this journey, you need to have the right people and the right skill set and the right mentality, because things are going to be a little bit different. So yes, I totally agree. Can't wait too long to hire the people that you need. You need the experts. You need the right skill set. You need the right interaction with the ecosystem. And then there is ways to do, well, how do you, and this is some of the things that we do in Intel, right? How do we create certain level of applications that hide some of the complexity, right? So you still need people with a skill set and people understanding the complexities of the mobile network. But can we also, for multiple applications that are going to that are going to run in that network, can we abstract, can we create level of abstraction that the majority of the programmers in the world don't have to deal with that complexity. And that's the thing, the type of thing that we're doing, for example, with openness. But you are absolutely right. You have to have the right skill set, and you have to think of what is going to happen, right? If you having different components from different vendors, you're going to have to integrate that, and you need to think on the integration, the system integration component and the system testing component of that of that project, right? And you need to think ahead of it. So yes, it is a new way to do things. So you need to have the right talent, and you need to do things in the right way. So it's a much more software focused and oriented. How do you do software? How do you deploy software? How do you maintain software at a low cost that maybe it was before.
Well, congratulations on so many amazing announcements, and certainly one of my favorite of late, the Atom P5900 System on chip. I can't wait to get one of those in my lab and see what we can do with it. I think it's really exciting that you have effectively lowered the barrier to entry to new and innovative ways to implement radio access networks, particularly in the virtualized space. I think the next 12 to 18 months are going to be quite an exciting, disruptive, but positively disruptive period for us, above and beyond the fact that we are currently enduring a global pandemic as we sort of work out what the new normal is. But when I start to think about what you're sharing today and some of the insights you've shared around what's possible, I love the idea that behind closed doors, people are sitting at whiteboards, plotting and scheming world domination with whole new exciting ways to do things that we have made some big assumptions around how they might have worked in the old way that now we haven't even imagined. And congratulations on making that possible. And for folk who've tuned in, we will have a number of links below in the show description to relevant key parts of the Intel web portals with web pages and information. We'll have links to various assets you can get to, and certainly reach out to Cristina on LinkedIn and throw all your curly, interesting questions at her and her team. And I think, to your point there, reach out to Intel earlier than later, sooner than later, and get those conversations going and avoid some of those potential risks of losing months or a year down the track trying to do it yourself. This is very much a collaborative experience. And I think, this is what Intel's fueling now, is this exciting, new, innovative, collaborative way of changing the way that we use telecommunications and how communication service providers can offer services. Thank you so much for making time. I really appreciate all the amazing insights and knowledge you've shared and some of the use cases. And we'll be watching very closely with some of the amazing things that are coming out of yourself and your team there at Intel Corporation. And I can't wait to see this actually change the way that I use the technology.
Thank you, Des. This was a pleasure, and it is such an exciting time. Thank you so much for having me.